So we need to confirm that the integral test can be applied to the given series. Then we need to use the integral test to determine the convergence or divergence of this series. Well, let's review what we know about integral test. So the integral test basically states that if f of x is a positive, continuous, and decreasing function for x lying on the interval from 1 to infinity, and f of n equals a of n, where n is any natural number, then the improper integral from 1 to infinity of f of x dx and the infinite sum from n equals 1 to infinity of an both converge and diverge simultaneously. So here, in our case, the infinite sum is 1 over 3 plus 1 over 5 plus 1 over 7 and so on. We can rewrite it as the sum of n from n equals 1 to infinity of 1 over 2n plus 1. Therefore, we get that an, so the nth term, equals 1 over 2n plus 1. So we let f of x be equal 1 over 2x plus 1 for x lying from 1 including to infinity. Then clearly f of x is continuous, f of x is positive, and it is decreasing because when x increases, the value of the function decreases. So that means, let me write it down. Here we have that it's continuous, positive, and decreasing. And f of n equals 1 over 2n plus 1, so it equals a of n for all natural n. Well, so that means that the integral test can be applied for f of x and an. So let's write it down. The integral test can be applied for f of x and an. So now let's check the convergence or divergence using the integral test. So first of all, we check the convergence or divergence of the improper integral from 1 to infinity of f of x dx. This equals the limit of the integral from 1 to t of 1 over 2x plus 1 dx, where t approaches infinity. Then this equals 1 over 2 times limit of the integral from 1 to t of 2 over 2x plus 1 dx, where t approaches infinity. Then it equals 1 over 2 times the limit of ln of 2x plus 1 from 1 to t, where t approaches infinity. Then this equals 1 over 2 times the limit of ln of 2t plus 1 minus ln of 3, where t approaches infinity. So this equals infinity. Since the integral equals infinity, that means that it diverges. And if this improper integral diverges, that means that our series also diverges. So